Okay, so now that we know what the coefficients in a chemical reaction tell us, we want to review really quick all the vocab, right? So hopefully you can identify, maybe take a highlighter and highlight in this chemical equation how each of these words apply. So for example, if I make coefficient yellow, hopefully you have an actual highlighter. Here's my coefficient there, and here's my coefficient here, right? And so you can kind of keep doing that. The superscript, there aren't any superscripts in here, but if we had like a metal, it might be an Fe3+. The superscript is this part. We do have subscripts in this chemical reaction, so we're going to highlight those in purple. They're the number that tells you how many of that atom are in that molecule. When we read the plus sign, we usually say reacts with. So we would read this as 2 molecules of hydrogen react with 1 molecule of oxygen, or you could think about it as moles, just like we talked about. The arrow can be read 2 ways. You can either say produces, I like purple, I keep picking it. You can either say that the arrow produces 2 molecules of water, or you could say yields 2 molecules of water. And then you have all your state indicators, right? So S means solid, L means liquid, and this can look confusing depending on the font. It might look like a 1, but this is an L right here. G is gas, and of course AQ we saw when we talked about acids. It means aqueous, so dissolved in water. We would not put water aqueous because you don't dissolve water in water. So watch out for that. It's going to come up in the experiment 4. And then of course reactants are everything on the left side. They're always on the left side. These are your ingredients. These are the things you put together to make the chemical reaction occur. And, oh, let's see. I guess we'll do black. The products are always on the right. That's your, what you're making, what you're producing. Okay. All right, so that's a quick review. This is the next law, is the law of multiple proportions. And what that says is if you change the ratio, so in water we have 2 hydrogen for every 1 oxygen, right? Or you can look at it as coefficients over here, 2 hydrogen molecules for every 1 oxygen molecule. That's from conservation of mass. If I change that ratio, if it's not 2 to 1 anymore, I change the chemical identity. Okay, so water is always 2 hydrogens, 1 oxygen. It's consistent. All chemicals are consistently the same ratios it doesn't matter where you take the sample or who measures it or whatever, you get the same ratios. The same empirical formula, right? If I change this ratio to, say, 1 hydrogen and 1 oxygen molecule, we will get H2O2. So this has a 1-to-1 ratio. It's simplified, right? So it's actually 2 hydrogens for every 2 oxygens, but they don't really come together as just 1 of each. So the simplest thing you can get is actually a chemical formula of H2O2. The empirical formula would be HO. All right, so it's not the same thing. If you drank hydrogen peroxide, you'll die. If you drink water, you feel hydrated. It's good for you, right? Hydrogen peroxide murders you. Don't do it. It's bad. Some people do use a diluted solution of hydrogen peroxide, which is what you can purchase at the store to whiten their teeth. As long as you don't swallow it, it's fine. But you definitely don't want to drink it like you do water. Okay? And so just changing the ratio, the coefficient in the reaction, you completely change the chemical identity. Okay? So here we have another summary of the same vocab terms. You can tell these are important vocab to understand. Okay? And now we come to writing chemical reactions. I have a really specific way of showing you how to do that. You're going to do this in the lab. Actually, you do it at home, but it's based on experiment 4 from the lab. Group B is going to write the reactions before they get to the lab. Group A is going to write them after they've done the experiment. it doesn't matter which way you go. The important thing is that you can figure out what state everything has. You know how to translate from the name in the procedure or on the bottle into a chemical formula, and you can balance the mass so that we don't end up with like creating matter or destroying it. Okay, so we're going to follow all these laws that we've talked about. So here's how I do it. We're going to use this phrase here: silver nitrate reacts with hydrogen sulfide to produce silver sulfide and nitric acid. So the first thing to do is I like to eliminate as much of the words as I can. So let me show you what I mean. Okay, so the first step in writing chemical reactions is to take these words and just write them down in a clear way, kind of removing the extra words. So silver nitrate, and then it says reacts with, that means plus, hydrogen sulfide, to produce means arrow. It might also have said yield. Silver sulfide. That sounds like a comic book character to me. And also means plus. Nitric acid. So I'm just taking the important bits and writing them down into the format that a chemical equation has. Then, this is a fun step, so I'm going to use my rainbow pen. Then we're going to translate, all right? And so this is where your skills with the naming from chapter 2 come in. So we have to know that silver is Ag and that nitrate is NO3. And we also want to keep track of the charges. So silver is a +1, always a +1. That's why there's no Roman numeral. And nitrate is a -1. So I need one of each of those. And it's going to react with hydrogen, well, that one's easy. Sulfide, I'm going to write over the hydrogen so you can see it better. There we go. Hydrogen. Sulfide means sulfur because the ending has just been changed to IDE, so sulfur is S. So if I go look on my periodic table, I'll see that that's a -2. Hydrogen is a +1 whenever it's in a covalent compound. The only time it's not +1 is if it's connected to a metal, which doesn't happen very often. So +1. These don't balance. I don't have enough positives, so I'm going to put a 2 after the hydrogen so that now I do have enough positives to balance out my negatives. So that's through hydrogen sulfide, and then I'm going to draw my arrow. Silver again, and sulfur again. So here it's a +1 and a -2. So I need to have 2 silver to balance the charge. Okay. Then I have reacts with nitric acid. So this one we've got to recognize. Ic was a nitrate. And so a nitrate is NO3. This has a -1 charge. And it has to be an acid. There we go. All right, so we're not quite done. By the way, when I was learning this in college, I bought a whiteboard to use, but you can find all kinds of free whiteboards on the internet if you have a way to write on your computer. So either I use a little electronic tablet thing, or you can also buy them for your phone. Like, not buy them, you don't have to buy them at all, but you can get Google Jamboard, J-A-M, board, for free, and you can use it like a whiteboard. And that's nice because you can erase things, and it feels a lot less intimidating that way for people. So I would suggest taking some, or get a lot of paper. I turn the page sideways because you need space. Anyway, so the next step, so we went words, that's the first one. I just like my rainbow pen, so I'm going to keep writing with it. We did words, and then we did chemical formulas. And when you're doing that part, that's where you're messing with the subscript. Okay? Don't worry that you don't have the same number on both sides. Take it a step at a time, okay? Don't crowd yourself in this process, all right? Because the next step, step 3, is going to be balance the coefficients. And you have to go in this order. You have to go subscripts first. So you're thinking about the charges of things. That comes from the periodic table or your list of polyatomic ions. Then you worry about the coefficients, okay? And so here's how I approach that. I'm going to do this one in, oh golly, let's do blue. What I like to do is there's an order to it. You start with the metals, okay? And so metals first. If there aren't any, you just skip that. But Ag is a metal, so I like to put that in the middle under my arrow. And I'm going to count. So on the left side, I have a total of 1 silver. It's right there. On the right side, I have 2. So to balance this, I have to put a coefficient in front. I cannot change the subscripts once I have decided what the charges are, that the charges are balanced. So coefficient. That means now I have 2 silver, but also 2 nitrate. I'm not going to worry about that. It's okay. All right. And I say that because a lot of people get really anxious about it. Just let it go. It's fine. And then I'm going to balance any nonmetals besides hydrogen and oxygen. And so we have an oxygen in this one, so I'm just going to ignore it. Hydrogen is right there, but sulfur, I haven't done sulfur yet. So there's 1 sulfur. This 2 applies to the hydrogen, not to the sulfur. So I have 1 sulfur on the left and 1 on the right. So that checks out. Good there. Oh, and I forgot to update this. I made 2 of those. So now that checks out as well. You could do nitrogen and oxygen separate from each other, but the polyatomics don't break apart pretty much ever. So I usually save myself a little bit of effort and just keep it together and do nitrate. So after we've done all the nonmetals besides oxygen and nitrogen, then I'm going to look at the polyatomic. And in this case, don't forget, the 2 applies to the silver and to the nitrate. So we have 2 on this side. We have 1 over here, so I'm just going to pop a 2 right into there so that I can have 2 of them, 2 hydrogen and 2 nitrate. And then the last thing to balance, in most cases this will be true, is I'm going to do hydrogen last. And so 2 hydrogen here because I have a subscript, and 2 hydrogen here because I have a coefficient. So by waiting for hydrogen at the end, most of the time, not always, it'll balance itself out. All right. So finally, our end product, and we haven't done states yet. That's coming up in a future video. For now, this is just the beginning. Oops, I didn't mean to move that. Undo that. I meant to move this part. So we end up with, well, we did know that the acid state at least, so we can put that down now. Okay? That's an AQ, not an AG. So that's your answer. That's the balanced reaction. Okay, so we're going to go on to another example. I want you to pause it now that you've seen me do it once, and I want you to try it on your own and then resume the video. Try to use the same method. Words translate into formulas, so you're messing with the charges then, the subscripts, and then you mess with the coefficients. So 3-step process. Okay, so here we go. The words that we're going to take out is magnesium reacts with oxygen to form, which is the same as saying to produce or to yield, magnesium oxide. Okay, so now we're going to translate. So we have words. Now I'm going to say, okay, well, magnesium is Mg, and that's a metal. So I know that's a solid. The only ones that are not solids that are, metals is mercury and cesium. No, not cesium. Well, mainly mercury. There's a couple of others, but it kind of depends on what temperature people are thinking about it at. But most metals are solids. Oxygen is a diatomic element, so we need to remember that that is O2, not just O. It's really important you know those diatomics. That's another thing you should be making flashcards for. You're going to have a giant pile of flashcards for a while. That's okay. All right, it's a good way to learn things. Oxygen is a gas. We breathe it in all the time. You should know that. If you don't, you do now. And then magnesium oxide is going to be MgO. And we want to check our charges. So Mg is in the second group on the periodic table, and oxygen's in the non-metal side of things. So if we look at oxygen, it has a -2, and Mg has a +2, which means I only need one of each of those. This is a kind of rust, much like iron oxide. Metal oxides are always solids, unless they happen to dissolve, which is pretty unusual. Really just group 1 things would do that. Okay, so now we have the right coefficients. This one was easier because we have 1 magnesium for 1 oxygen. The next step is to look at balancing the coefficients here. So metals first. Magnesium, we have 1 on the left, 1 on the right, so that's easy. And then we'll look at oxygen. Since there's no other nonmetals here, you have 2 on the left and only 1 on the right now. So to fix that, what we're going to have to do is add a coefficient. We have to, because I need to have 2 oxygen, because oxygen is diatomic. So that fixes this one, but it also messes up the magnesium. But that's okay, I'll just come back to it and put a 2 in front of that one. And then everything checks out and it is completely balanced. This is a really cool reaction. It creates a lot of white light. So watch the types of reactions lab, and you'll learn that this is called a combination reaction. Somebody in one of my lectures asked for guidance on balancing combustion reactions. So I'm going to put a new problem in here. And so it'll say, go back to my, So we're going to say that, let's see, let's burn propane. Okay, propane. And I don't expect you to know the name of propane. I'll give you that formula. Propane has the formula C3H8, which if I gave you this, we would have named as tricarbon octahydride, which is not a thing, by the way, but that's the rules we would follow. When you go into organic chemistry, you get to learn how to name those carbon-containing compounds properly. For now, if I want you to look at combustions, I'll tell you what the formula is, so don't worry about it. Propane is actually a gas. It's compressed in a cylinder, so it sounds like a liquid, but once you let it out, it's a gas. All combustions require oxygen, so you have to remember to add that in there. It comes from the air, so it's not like you're going to pour it into your reaction, so sometimes people forget it. But you have to have oxygen to burn anything, so you can't have a barbecue in space, which also means most sci-fi shows are wrong. All right, and then your products are always carbon dioxide, which is what we breathe out, and water vapor. This is hot because it's on fire, right? That's the hallmark of a combustion reaction. It's on fire. All right, and so to balance this, you know, when you do combustion reactions, sometimes you go back and forth quite a few times, but figuring out what the products are is actually pretty easy. Just remember, it's always carbon dioxide and water. And your reactant is whatever the fuel is, usually hydrogen and carbon, reacting with the oxygen. And we're going to follow the same order. There's no metals here, so we'll do carbon first. I have 3 on the left, which means I have to put a coefficient of 3 on the right. I prefer to look at hydrogen next because oxygen occurs in 2 places on the right side, on the product side, so it's easier for me to look at hydrogen first. We have 8 here, and so we have to, in order to get 8 on the right, I have to have a 4, because 4 times 2 is 8. Okay, and then oxygen, right now I have 2 on the left. I know I'm going to change that. On the right, I have 3 times 2, and I have 4 from the water. Don't forget that. A lot of people forget it. And so overall we have 10. So to get 10 oxygen on this side, I'm going to have to change this so the coefficient is 5, because 5 times 10, 5 times 2 is 10. And so that's the balanced reaction for propane combustion. You follow the same process. Sometimes, for any hydrocarbon burning, sometimes you'll get to a point where you end up with like an odd number of water molecules. If that happens, you have to double everything, because you can't get an even number, you can't get an odd number of oxygens, because there's 2 here, and whatever you multiply by 2 is going to be an even number. Okay, so just double the whole thing if that happens.